Applicability of memento pattern. This pattern is used to restore objects back its to previous state, and we can say example as undo and rollback operations for that restoring of objects that can be performed in real time. Examples are we are using examples are for undo operations is Word documents or PowerPoint or some other notepads, Excels. These are the examples we can say for this memento pattern. Coming to the applicability of this memento pattern, it is used in undo and redo operations in most of the software. That means we can consider that we are using the memento pattern in MS Words or Notepad, Excel or PowerPoints. This memento pattern is basically it is used in every applications that to perform undo and redo operations. We are using in all applications of memento pattern that which supports all the type of application that to perform undo and redo operations. And some of the applicabilities of this undo and redo operations under memento pattern is a snapshot of an object state must be saved so that it can be restored to that state later, and a direct interface to obtaining the state would expose implementation details and break the objections encapsulation. These are the two applications we can say under this memento pattern. And our next template is structure. This is the structure of memento pattern. Here we consider the three classes of originator, memento and caretaker. So, in this memento, these component store the internal state of the originator object when it changes the classes. It stores all the internal states of the objects when it has been changed. That can be done by this memento class. In the coming to the originator uses the memento to know the state of the object that to perform undo and redo operations on an object. And the next one is caretaker. So, this caretaker is the responsible for restoring the current and previous states of an objects. So, this is the structure of a memento pattern. Based on this structure, we consist of three participants. The first one is originator, memento, and the next one is caretaker. So, in this memento, it stores the internal state of the originator object. The memento may stores as much as little or the originator internal states as necessary as its originator's discretion. And coming to the originator, it creates a memento containing a snapshot of its current internal state, and it uses the mementos to restore its internal state. And the next one is caretaker, that which will become as a responsible for mementos safekeeping. It never operates or examines the contents of a memento. We can say an example for a mechanism for this caretaker is undo operations. So, these are the three participants we can say under this memento structure. So, and the next one is coming to collaboration. A caretaker, we consider here three objects. We consider here a caretaker, originator and a memento. A caretaker requests a memento from an originator, holds it for a time and passes it back to the originator as the following interaction, as the interaction diagram shows here. Sometimes the caretaker won't pass the memento back to the originator because the originator might never need to revert to an earlier state, and these mementos are passive. Only the originator that creates a memento will assign or retrieve its state. And the next template in our design pattern under memento is consequences. Each and every pattern has number of consequences. In the same manner, this memento pattern has several consequences. Coming to the consequences under these memento patterns are The first one is preserving encapsulation boundaries. That means Memento avoids exposing information that only an originator should manage but that must be stored outside the originator. The next one is it simplifies originator. That means in other words we can say that encapsulating preserving designs originator keeps the versions of internal state that client have requested. And the next one is using mementos might be expensive. Mementos might incur considerable overhead if originator must copy large amount of information to stores in the memento, or if client creates and retains mementos to the original of them. Coming to our next consequences, defining narrow and wide interfaces. That means it may be difficult in some languages to ensure that only the originator can access the mementos state. That means in some cases, in some applications or in some programming languages or in some languages, it may require some of the cases to store the memento states. Coming to our next consequences, hidden cost in caring for mementos. A caretaker is responsible for deleting the mementos it cares for. However, the caretaker has no ideas how much state is in it memento. So that it will become as a lightweight caretaker might incur large storage cost when it stores mementos. So we can say this is one of the disadvantage. So these are the 5 consequences that we can speak under our memento pattern. The first one is preserving encapsulation boundaries. It simplifies originator. Using memento might be expensive. Defining narrow and wide interface. Hiding cost in caring for mementos. So these are the consequences. And coming to the implementation, here we can see 2 issues that can be considered when implementing the memento pattern. The first one is language support and the next one is storing incremental changes. In this language support, mementos have 2 interfaces, a wide one for originators and a narrow one for the object. Ideally, the implementation languages will support 2 levels of static protections. Suppose if we consider C++, you do this by making the originator a friendly of memento and making mementos wide interface private. Only the narrow interface should be declared public. So this is one of the example we can say in C++ programming language for implementing this memento. And coming to the next one, storing incremental changes. When mementos get created and passed back to the original originators in applicable sequence, the memento can save just the incremental change to the originator internal state. And we can say an example for this is undo commands in our undo history or history list in a command history. We have seen the command history in our previous concepts, in that we can say undo and redo operation based on the command history list. So these are the 2 implementation issues raised while implementing this memento pattern, large supports and storing incremental changes. And our next template and the last template is related patterns. Coming to these related patterns, we can say command and iterator are the related patterns to our memento pattern. Commands can use mementos to maintain state for undoable operation. And coming to the iterator, these memento can be used for iterations as described earlier. So based on these, we can say this command and iterator will become as an related patterns to our memento pattern. So this is about our memento pattern. So finally we say that simply to justify our intent, we say that this memento pattern is used to restore the state of an object to its previous state, and this memento captures an object's internal state so that the object can later be restored to that state based on our client request, based on our request. That means to perform an undo or redo operations in an application. So this is one of the example we can say for this memento pattern. So, this is about our memento pattern.